All right, starting off at number 4 here, we're going to find all of the zeros, real and complex. So I always want to kind of look at factoring first. So on this one, I see I can GCF an x, which gives me x squared plus x plus 1. And then I'll try to factor this multiplying to 1 and adding to 1, but that's not going to work. So I'm going to have to switch to quadratic formula here. So we get negative 1 plus or minus the square root of 1 minus 4 times 1 times 1, and all over 2 times 1. So that's going to turn into negative 1 plus or minus the square root of negative 3 over 2, which I would then write as negative 1 plus or minus I rad 3 over 2, which you could also split up into negative 1/2 plus or minus rad 3 over 2I to get it in that a plus bi form. So now it's asking me to factor it completely, so I want to kind of include that idea that I can use these imaginary zeros as well as my real zeros. Oh, I didn't list my real zero at 0 since I took out that GCF right there, so I probably should have done that. But now, to write this in the fully factored form, I would always just say, well, we need the x still out there, and then I'm going to always say we just do x minus the 0. So our 0 here, and I'm going to write them a little bit more neatly, would be negative 1/2 plus rad 3 over 2i. So I would write that as x plus 1/2 minus rad 3 over 2i. So we always want to kind of change the signs when we're building the zeros there. And then the other one would be negative 1/2 minus rad 3 over 2i because of the plus or minus. And so that one, once again, I'm going to change the sign to plus 1/2 and then plus rad 3 over 2i. So that's my answer for part B, fully factored. Next up, number 6, I see that this is a trinomial. There's no GCF, but I see that it has this pattern of the second power is half of the first power. So I'm going to try to factor this, adding to negative 1 and multiplying to negative 2. So that's negative 2 and positive 1. But it's just going to be x squared minus 2, and then x squared plus 1. So then if I wanted to find the zeros, I could just split these up and set them equal to 0. So this one would say x squared equals 2. This one would be x squared equals negative 1, so I take a square root, so this one would be x equals plus or minus rad 2, and this one would be x equals plus or minus I. And so those are my zeros for part A. So then for part B, once again, I can just build the factors based on x minus the zeros. So I can do x minus rad 2, x plus rad 2, x minus I, x plus I. All right, next up, number 8 is again factoring here. It's a trinomial, so I can do an x box. So 9 and 6 would be 3 and 3. So I'm going to get x squared plus 3 and then x squared plus 3 again. I can just set one of those equal to 0. So x squared equals negative 3. And so x equals plus or minus I rad 3. And then since this one would actually be the same, what I would say is I have x equals I rad 3 with multiplicity 2. And then we also have negative I rad 3 with multiplicity 2, since we have kind of two parentheses doing the same thing. So that would be my answer for part A. For part B, once again, I would just do x minus the 0, or change the sign of the 0 to build this. So I got x minus I rad 3, and then since that's multiplicity of 2, I would square it. And then for the negative I rad 3, I would say x plus I rad 3, also to a multiplicity of 2, so I'm going to put the exponent up there. All right, next up we have number 10. So for this one, this would be perfect cubes here. So I can do these whether they're adding or subtracting. So we just do the cube roots here. And then the second one, we do the first term times itself. And then the two terms multiplied together, and then the last term multiplied by itself. And then our signs are going to be, since this is a minus, it'll be same, opposite, and always positive. All right, so now we know x equals 2 based on this one. For this one, we got to use quadratic formula. So negative b plus or minus square root of b squared minus 4ac all over 2a. So we get negative 2 plus or minus the square root of 4 minus 16 would be negative 12 over 2. And I'm going to need some more space. Let me go over here. Okay, so 12 is 4 and 3, which is 2 and 2. So this will be negative 2 plus or minus 2I rad 3 all over 2, which will just simplify into negative 1 plus I rad 3, and then also negative 1 minus I rad 3. So I got my 3 answers for part A there and over there. Now for part B, the fully factored form, once again, I want to just do x and then change the sign of each of my zeros. So this will turn into plus 1 minus I rad 3, and then x plus 1 plus I rad 3. All right, next up here, we're writing polynomials given the zeros. So obviously for negative 3, we always switch the sign here. So we'll write it as x plus 3. And then for this one, we have to switch both of the signs. So that'll be x minus 1 minus I. And then there's actually another one here that they're not telling us about. They're not supposed to tell us. We kind of have to know. The conjugate zeros theorem states that if we have an imaginary 0, then its conjugate is also by definition a 0. So since that is also a 0, I can switch the signs on that and build another factor. So now I'm going to build my box here. And I like to multiply these, the imaginary ones together first. The imaginary terms should all cancel out by the time I'm done. So I'm just going to multiply these together. And then we got negative I right there, and then negative I squared. And so, all right, what we see here is that negative ix cancel out with ix, negative I with I, and then this negative 1i squared actually turns into a positive 1. So I can rewrite this now as x squared minus 2x, combining these x's right there, and then plus 2, combining my real numbers here and here. This still needs to multiply by x plus 3, so I need to do one more box. So I'm going to do x plus 3 right there. So we get x to the third minus 2x squared plus 2x. And then 3x squared, negative 6x, and then positive 6. So I can just combine like terms to write my final answer, which is x to the third plus x squared minus 4x plus 6. All right, next up, number 38. So same idea here. So we have x minus 2i, and then this one's going to be x minus 3i. However, once again, I know that these conjugates, negative 2i and negative 3i, are also zeros. So I can put x plus 2i there, and then x plus 3i there. You'll notice that I put these conjugates with each other because it's always easier to multiply these because we can do a fl. And so this one will be x squared, and then minus 4i squared is actually plus 4. And then this one will be x squared, and then negative 3i squared is actually negative 9i squared is actually plus 9. So now I need to multiply these together, and these are not conjugates, so this will require a full FOIL. And so it's x to the fourth, 4x squared, and 9x squared is 13x squared. And then plus 36. All right, next up here, it says we got zeros at 1/2, negative 1, and I. And so I know that if negative I is there, that positive I is also there. And then the 0 at negative 1 has a multiplicity of 2. Okay, so let's do this all out. So 1/2, I would write it as 2x minus 1. Negative 1 is multiplicity of 2, so that one should be squared. And then I have x plus I and x minus I. I see that that does give me the degree of 5. The leading coefficient, I'm going to save that till the end. I'm just going to expand this first. So I'm going to leave the 2x minus 1 out here. We'll write this twice and FOIL that. So that'll be x squared plus 2x plus 1. These ones I can do a flu because these are conjugates. So that'll be x squared, and then negative I squared is actually plus 1. All right, what are we going to multiply next? I would actually multiply this one and this one next. So then I can just do a triple times a triple. You can multiply in kind of whatever order you want. So this will be 2x to the third. Let's see, minus x squared. And then plus 2x, and then minus 1. Oh, so this actually won't be a triple times a triple. It'll be a triple times a 4. All right, so we'll have to do that. Cool. So I'm going to put the x squared, the 2x, and the 1 there. We'll multiply this out. Okay, so that'll be 2x to the 5th, negative x to the 4th, 2x to the 3rd, negative x squared, 4x to the 4th, negative 2x to the 3rd, 4x squared, negative 2x, 2x to the 3rd, negative x squared, 2x, and negative 1. We'll combine all of our like terms here, so that'll give me 2x to the 5th, plus 3x to the 4th, Let's see, we're going to have 2x to the third, and then we have 2x squared, and we have minus 1. Okay, so then lastly we need the leading coefficient of 4. So right now the leading coefficient is 2. So I'm going to have to multiply that by 2, give me 4x to the 5th, plus 3x to the 4th, plus, oh no, I got to multiply that by 2 as well. Excuse me. 6x to the 4th, 4x to the 3rd, 4x squared, and then minus 2. So that's my final answer. All right, next up I got number 42. So for this one, I first, whenever it's 4, I check kind of the ratio here and see if grouping will work, but it looks like it will not because they're not in the same ratio, the first to second term and the third to fourth term. But if it is, I can always do grouping. So instead, I'm going to have to use P over Q. So I got plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, all over plus or minus 1 for the one out front. Let's see, I'm going to try my plug-in-1 trick. So 1 minus 7 plus 17 minus 15, that definitely does not equal 0, so 1 is not going to work. I'm going to go ahead and try 3. So we got 1, 3, negative 4, negative 12, 4. Oh no, that's actually 5. And so that makes that 15, so that does make that 0. Okay, so this will work out x minus 3 times x squared minus 4x plus 5. All right, so now I'm going to try factoring this, multiplying to 5 and adding to negative 4, but that actually doesn't work. You can't really make those negatives work out, and so that means I'm going to have to switch into quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac over 2 times a. So that's 4 plus or minus the square root of 16 minus 20 is negative 4 over 2. So 4 plus or minus 2i over 2, which would just reduce to 2 plus or minus I. So I got that, and then I also have positive 3.